Why are water footprint methods not standardized globally? Have you ever wondered why there isn't a universal way to measure water footprints? This question is more complex than it seems. Water footprint methods vary widely around the world, and several factors contribute to this lack of standardization. First, let's talk about local environmental conditions and water quality standards. Water footprint assessments look at three main types of water: blue water, which is surface and groundwater; green water, which is rainwater used by plants; and gray water, which is the water needed to dilute pollutants. The gray water footprint is especially tricky because water quality standards differ from one region to another. Each area has its own rules about what levels of pollutants are acceptable. This means that a universal method cannot easily account for local needs and conditions. Next, we have the conceptual challenges in defining water loss and impact. There is ongoing debate about how to classify certain types of water use. For example, should gray water be seen as lost from the system or as potentially reusable after treatment? Unlike blue and green water, gray water can remains in the hydrological cycle if treated properly. This makes it hard to create a single metric that accurately reflects sustainability and water availability. Another reason for the lack of standardization is the different objectives and approaches among methodologies. Two main groups have developed water footprint methods: the Water Footprint Network and the Life Cycle Assessment Community. The Water Footprint Network focuses on measuring water productivity and the total volume of water used for products globally. On the other hand, the Life Cycle Assessment Community looks at the environmental impacts related to water use. These differing goals lead to variations in calculations and communication, making it tough to unify methods into a single global standard. Additionally, water footprinting is often used as a tool for raising awareness about water use hotspots. However, it is not designed to replace comprehensive water management approaches. Because water footprint methods are applied in various contexts, such as agriculture and industry, standardizing them globally would require harmonizing with complex, region-specific water management policies. This is a challenging task. Finally, data quality and uncertainty play a significant role. Water footprint assessments relying on data about water use, availability, and quality. However, this data can vary in quality and completeness across different regions. The models used to estimate water footprints also involve uncertainties, especially when assessing impacts. These uncertainties further complicate efforts to create a universally accepted standard. Despite these challenges, there are ongoing efforts to improve consistency. The Water Footprint Network has published a water footprint assessment manual to guide practitioners. The International Organization for Standardization has also issued guidelines suggesting that water impacts be broken down into multiple indicators instead of relying on a single number. This approach acknowledges that water use impacts are complex and cannot be fully captured by just one metric. In summary, the lack of global standardization in water footprint methods reflects the complexity of water systems, regional differences in water quality and availability, and varying methodological goals. While water footprinting is a useful tool for understanding water use and encouraging sustainable practices, it must be applied with consideration of local contexts and integrated with broader water management strategies.